So here's a fun little problem. We have a sentence that reads this. This sentence has blank letters. And so the idea would be plug in a word here that makes the sentence true. And so one unique solution we could come up with is count all the letters. And if we put in, that comes up to 22. So if we plug in the numbers 22 here, we could say, well, that makes the sentence true. Done. But that's no fun. So this letter has 22 letters. Since the 2 and the 2 are not letters, they're numbers, that would make it true. But we're looking more for a solution where we put in words here. So we're going to need a couple of functions here. One, I need to be able to change because I'm probably going to set up a loop to go through possible solutions for the number. But then I want to change those numbers into the actual words to fill in. And so to do that, I'm going to need a function, and I'm just going to call it num to word. And what I'll do is feed it a number value. So we need, we'll put in int, and that'll be my prototype for a function called num to word. I'll need one more because after I have it in word format, I need to know how many letters that word is. And so I'll create an integer function called letter count, and we'll feed that a string value, most likely that we've gotten from num to word. Okay, and that'll take care of my prototypes for the two functions. I'll go ahead and go down to main here, and we'll start creating the main function. Even though we don't have these yet, we'll go ahead and set up our solution here. And then we'll define the functions later on. So first thing I want to do is set up these sentences. So string, and we'll create the first part, we'll call it phrase 1 is equal to the sentence has. And then we'll set up, well, the second part I guess would be the word here. So we can set up another string called phrase 3 to put the last part of the sentence in. And that way we have the two pieces of the sentence. Later on we'll use a variable to sandwich in our actual word there. And the other thing we want to do to make this a little more dynamic in case we change, I guess, the way the sentence is phrased, we don't want to just count on or hard code the number 22 in here. So I'm going to create a variable called phrase count, let's say, and we will count all the letters in the initial phrase. So that would just be phrase 1 or the letter count of phrase 1 plus the letter count of phrase 3. So I'll use my function even though I haven't defined it yet. We'll assume we'll do a good job later and make that work. So letter underscore count of phrase 1 plus the letter count of, we'll put phrase 3 in there. And that'll take care of that initial statement. And then we can actually start working on our loop here to go through the possible combinations. So we'll use our old standard I equals 0 and go up through the total that we think it might be. And actually to save a little bit of calculation power here, we don't need to start at 0. We can actually start at, since we know there's at least 22 or whatever phrase count comes out to be, we'll start at phrase count and we'll go up to whatever we think a good number is. I'm going to pick 99 as my max because that's well beyond what I think we're going to need, and it will kind of simplify when I create my function num to word. I only need for that to work up to 99, so 2-digit places. And of course we'll get there by 1, so we'll kind of brute force through all those to see if any of them match and give us a true statement. We'll set up our for loop, and in here I'll just do an if statement to see if the whole phrase adds up appropriately. And all I'll do is look at each value of I. So I'll start with I and compare that to, we'll start out with the num to word of I. And we'll need to, so for each number, convert it to a word, and then after we have that word, we're going to feed that to the letter count function to count the number of letters in that word. And that gives us the letter count for the numeric value of, say, 22. And then we're going to add that to the phrase count, okay, to get the total count of letters in the entire sentence. And that should be a good condition right there for the if statement. Then all we would need to do is output our result. And so we'd piece the phrase back together. And so we'd see out phrase 1, that part. And then we need our number in here, but we're going to do num to word so we can put it in word format of I. And then we'll add in our last part, phrase 3. And that should be our solution. Go ahead and put an inline on there just in case there's more than one. We'll put them on separate lines. And that's that. I mean, pretty short and simple solution, of course, with these black box functions. So we need to create those functions now for this to work. So I'll start out with num to word. So we'll string num to word, and then we need to pass in an integer. So I'll just put in an x will be my internal or local variable for whatever values passed in for num to word. And then we'll do a string part 1. So if you think of the parts of a number word like 22, we can treat most of the 2 digits separately to get part 1, but we'll initialize that to blank. And then the second part, so we'll create another string called part 2 and initialize that to empty string as well. And then we can start looking at our values here. So we can do a switch on X. And initially, I'm just going to look at special cases that I know there are going to be some things that are just different. There's no great programmatic way to take care of them. So I'm just going to say case 0 for the first one and go ahead and put part 1 as equal to 0. Okay. And then for case 10, same thing. I'm just going to go ahead and put in 10. And be done with that one. Case 11 is special, and we can keep going all the way up to 19. We're just going to go ahead and do that. I guess we could do it for all the numbers to 99, but I don't want to type that much. So after that, we're going to have a default. So if it's not any of these special cases, we're going to handle it in this second part. And I want to break it into 2 parts. So I'm going to get the tens part. And so we'll do that by taking x and integer divide by 10. That'll give me the first digit in the 2-digit number. And then we'll do the next part, the ones part, and do x mod 10 to get the remainder. That'll give me the first digit in the ones column. And we'll take a look at these. We'll switch on the tens part first. And first thing would be case 2. Would be 20, right, in the tens column. So we will go ahead and say part 1. If we get a 2 in that column, we'll set to 20. And then if we get 3, of course, that would be 30. And so on down the line, we can go all the way up to 90 with that. So that will take care of pretty much the first or the tens digit, the first part all the way up to there. And then we'll look at the ones part. If the ones part is equal to 1, remember ones is just the first column, right? The ones column, we did the x mod 10. So we'll do the second part of the 2-part number word, and we'll just set that equal to 1. Okay, and then the same thing for 2 through 9. If 1 equals 2, part 2 is equal to 2, and so on down the line, 3, 4, all the way up to 9. It'll take care of that, and then all we need to do is return part 1 concatenated with part 2. and we'll have those two parts together as a string. Okay, so remember those are string variables. Okay, so that should take care of the first part. The second part, remember we had the letter count function, so we'll create that here, letter underscore count, and we fed in a string to that. I'll just call my string word that they feed in, and we will count the number of letters in there. So I'm going to create an int c that I can return later. We'll set it equal to 0 to start out with, and then we can add to that as we find characters. And so for int, I'm going to go from the beginning of the word, so I equals 0, up until I is less than the word length. So we'll go all the way to the end of the word, and of course get there by 1. That sets up our loop to count. Then we need to check to make sure the position in the word we're on is actually a letter character and not a number or a space. And so we'll do if is alpha is a function that will tell us it's an alpha character of, and we want to look at one particular part letter by letter. So in the word sub I, okay? And so we'll look at each character as we go through each character of the loop from 0 all the way to the end. And if is alpha, then we want to add that in. So we'll do C++ to add that to our count. And that's pretty much it. The only thing left to do is return that value C. And that should be the end of our function. If we scroll back up here, we should be ready to run this. Just kind of curious, it's like, well, before we run it and look at the answer, we might want to test out our function like num to word and see if it's working. So to test it out, I don't want to test it out to phrase count, so I'm going to go ahead and put 0 back in for this loop. I'm going to comment out for right now our actual solution, and I'm just going to add in a test line of code here to test out my function, and I'm just going to do cout, and then I'm going to call the num to word, and I'm going to go through from 0 up to 99 because that's what I expect my function to work with, and we'll just pass in I. And then the second one, we're going to do this, we're going to do the letter count of the num to word to see if that part is working okay for all the numbers. And so we'll do that with a space in between, and we'll do the letter count of this part, num to word of I. And we'll do the inline for that, so we do 1 on each line. Let's compile and run that and see what we get. And looks like we're doing pretty good. If I scroll up through my results here, it starts with 0. Remember, this is not the numeric value 0, it's the count of the letter. So 0 has 1, 2, 3, 4 characters, 1 has 3, 2 has 3, and it looks like it's counting through. I got our special cases in here, 11, 12, 13, 14, 19, 20, 21, 22. And we scroll through, and this is looking pretty good. So I think the functions, both of the functions are working. So we can go back and change this back up again, uncomment those the statements. We'll just comment that out and uncomment our actual solution. Again, we can change that 0 back to phrase count because we don't really need to check anything less than the phrase already. And that should give us what we're looking for. So we'll go up and compile and run this. And it looks like it gives us 2 solutions that work out. This sentence has 31 letters and this sentence has 33 letters. So kind of an interesting problem and not too bad of a solution. It gives us a chance to look at modularization a little bit. So hopefully this was a fun puzzle for you, and I guess I'll see you next time.